Here is the solution guide for the limits test study guide. First problem, we see the limit as n approaches infinity of this rational function. An infinite limit, we're looking, since we have a couple of polynomials here, for the highest exponent, which is located in both the numerator and the denominator. So therefore, it's time to check out their leading coefficients. So we have 4 in the numerator. We have the unwritten 1 right there in the denominator, 4 over 1, or 4. Let's zoom in a little here. Alright, there we go. For problem number 2, you're given this graph of the function f, and you're asked at what values of x, which they call c, where, when x approaches c, does the function equal 1? Right. Well, why don't we do this? Let's just get a line going at y equals 1. Okay, so we're interested when the limit of the function is equal to 1. In other words, we're interested in when the function is approaching this line y equals 1 from both the left and the right. So let's move over to the left side. We see this point right here. Now, f does not exist at x equals negative 2. But as we approach from the left and as we approach from the right, in both cases we are heading towards 1. And again, what the idea is that the limit as x approaches negative 2 from the left of the function is equal to the limit as x approaches 2 from the right of the function. They're equal to each other, and in both cases they're equal to 1. So 2 checks off. That's part of our answer. Okay, so you're out and you're out. Now we move to the next spot that they recommend, which we see is 0. Okay, here's x equals 0. As the function approaches, or as x approaches 0 from the left and from the right, we are heading towards 1, and it turns out that f of 0 is 1. So 0 is also an answer. Now we go to 3. As x approaches 3 from the left, alright, so I'm going to change this here. This is x approaches 3 from the left. Okay, we get 1. Alright, that's going to be equal to 1. As x approaches 3 from the right, the function's heading towards something like a half. Alright, so the two are not equal to each other. 1 does not equal a half. So they're not the same. So it's just 0 and negative 2. Okay. Problem number 3. Here's f. It's a piecewise defined function. We're interested in the limit as x approaches 2 of the function. So the limit as x approaches 2 from the left, that's numbers just a little bit smaller than 2, like 1.9. 1.9 falls in this condition. So we're going to plug into this top function right here. We can plug in 2 because it's close enough to 2 that it does the work. So we have the natural log of 2. Now we also have to look at the limit as x approaches 2 from the right of the function. 2 from the right is like 2.1, 2.2. Those numbers are between 2 and 4, so we now have to use the bottom function. Again, we're interested as x gets really, really close to 2, so we can basically plug 2 in to this function. So we're going to find the limit as x approaches 2 from the right of x squared natural log of x, which means we're going to plug 2 in here. So we have 2 squared times the natural log of 2, or 4 natural log of 2. So now the question becomes, does the natural log of 2 equal 4 times the natural log of 2? Obviously not. Okay, ln 2 does not equal 4 times the natural log of 2. Alright, what does that mean? It means the limit as x approaches 2 from the left of the function does not equal the limit as x approaches 2 from the right of the function. And if the two one-sided limits are not the same, then your limit does not exist. Okay, last problem on this page. Here's our function y equals ax plus b over x plus c. And the graph of this function has a horizontal asymptote at y equals 2 and a vertical asymptote at x equals negative 3. Okay, so we have to figure out what a plus c is. Let's start with the vertical asymptote because that's our pre-calculus. Vertical asymptotes, if they occur, we're looking for the denominator to be equal to 0. So x plus c must be equal to 0, and we know x is equal to -3 when there's a vertical asymptote. So -3 plus c is equal to 0. Add 3 to both sides, and c is equal to 3. Okay, we need a plus c, so we're halfway there. Let's figure out a now. Guess what information we're going to use? The horizontal asymptote. The horizontal asymptote can be found by taking the limit as x approaches infinity of our function. So limit as x approaches infinity of ax plus b over x plus c. Okay, so we have limit as x approaches infinity. We've got a rational expression. Where's the highest exponent located? If you said both the top and the bottom, you are correct. We have x to the first, we have x to the first. So what do? We focus on the leading coefficients, which are a over 1. Now, a over 1, that's our horizontal asymptote. But we're also told our horizontal asymptote is equal to 2. So this limit is equal to 2, and specifically, a over 1 is equal to 2. So a is equal to 2, and a plus c is equal to 5.